Okay, so yeah, welcome back. I want to look at the next question, which says a car starts from rest, accelerates at 0.8 meters per second squared for 10 seconds, and then continues at a steady speed for a further 20 seconds. Draw the velocity time graph and find the total distance traveled. And so, this is simple. They say we should draw the time graph, so I'm just going to draw my two axes like this. And so velocity is always here on the y, time is here, and so this point is 0. Okay, so they are saying that it accelerates at 0.8 meters for 10 seconds. And so what will be the velocity for that? So the velocity will be equals to the acceleration times the time, which is just 10 times 0.8. This gives us 8 times 10. This is just 8 meters per second. So it goes like this. When it gets to 8, let's assume here's our 8 meters per second, and the time used is just 10 seconds. It said it then continues at a steady speed. So when it gets here, it continues horizontally for 20 seconds. So 20 seconds. So adding 20 to the 10, that's 30 seconds. Draw the velocity time graph and find the total distance traveled. And so find the total distance becomes easy. And so we find the area here and the area here and add the two. And so area 1 is equal to half base times height. What is the base? The base is 10, the height is 8. So this is just 40 meters. Area 2 is this square or the rectangle that is here. So that is 20 times the height, which is 8. And so this gives us 160 meters. Now adding the 2, so total distance becomes 40 plus 160. This is 200 meters. That's all for that question. Very simple one there. So we move on to look at the next one, which says that a car accelerates from rest to reach a certain speed in 10 meters. Oh, it starts from rest. That is one thing to note. So since it starts from rest, the initial velocity here is 0. And then reach a certain speed in 10 seconds, 10 minutes. And 10 minutes here is equivalent to 10 times 60, giving us 600 seconds. Okay, so reach a certain speed in 10 seconds. It then continues at this speed for another 10 minutes. Oh, and decelerate to rest in further 5 minutes. They are now saying that the total distance covered is 17.5. Oh, then I have to draw the graph. Very simple one. Let me use red. So oh, my line is not straight, but let me just leave it like that. So they are saying that it starts from rest, so it means this is always our V and this is our T in seconds. So it starts from rest and reach a certain speed. So let's assume that the speed, we don't know it, We can put x there. So as it starts here, it reached that speed. When it reaches there, and it uses 10 minutes, and this 10 minutes is equivalent to 600 seconds. So 600 seconds. It then continues at this speed for another 10 minutes, so another 600. So we go on, so another 600, meaning this one will be 1200 seconds, and then decelerate in further 5 minutes. So it comes down. So further 5 minutes means 300 seconds added to 1200, making 1500 seconds. So we have this. They are now saying that we should the total distance. So they've given us the distance. So distance is equals to 17.5 kilometers, which is equivalent to in meters. That's just 17.5 times 1000. That's 17500 meters. Okay. Now they are saying that we should find the steady speed reached. Okay, so that is very simple. We know that the total distance traveled. So we know that the distance traveled by this is a trapezium. We know that the distance is the same as the area. So area is equals to D, is equals to half sum of the parallels. So 1500 plus plus 600. This one parallel side, and this is another parallel side. These places. So here is 1500, and here is the 600. So 600 times the height. What is the height? Which is our x. Okay. This one should give us our the distance, total distance. That should give us 17500, like this. And so we take this one. We take this part and solve. And so we will now have let me say that 2000. Okay, so we have 2100x all over 2 equals to 17500. Yeah, 1500 plus 600. Yeah, anyway, 2 you get, so you get 1050x equals to 17500. So divide here by 1050, this and this goes. So therefore your x is equals to, so I have 17500 divided by 10050, and you are getting 16 whole number 2 over 3 meters or so. So meters per, I think we are looking for the speed, steady speed. So, and that's the value of our x, meters per second. Good. And that's all for this particular question. Yeah, find the steady speed reached. That's all. We don't need to do any this. That's all for this particular question.